started.
So in Unit 3, we discussed the units of measurement, our inches, feet, meters, and so on. In this unit, we're going to discuss, well, two things. There's some basic algebra that we're going to do, and we're going to be looking at the measuring devices. And our first measuring device, pen to work right here. There we go. First measuring device we're going to look at is a simple ruler. We'll look at them a little bit more tomorrow. Then we will look at calipers, micrometers. We'll look at other gauges, reading generic gauges and meters. And really just figuring out what the scale means. So if I'm on a ruler here, we've all used a ruler or a tape measure enough to know how it works. There's a zero end of the ruler, which is where the numbering starts. The tape measure, of course, it's the exposed end. And it is labeled. This is labeled that it's going to be measured out in inches. And we have those units marked out and numbered so that we can just hold the ruler up next to an object and read off what the measurement is. So the object we're going to measure, we hold it next to the zero end. We line it up with the zero end. For the tape measure, of course, we would use the hook. And we see where it goes. Like that blue line there, that is closest to the 2 inches. Now you might say, well, it's pretty close to halfway. Could we call it 2.5 inches? The answer is no, because this measuring device does not go to the half inch. We have to be careful to report the measurement in such a way that it honestly portrays what the capability of the measuring device is. This measuring device does not go to a half inch. We cannot report the measurement to a half inch. Now if I put another line on there, like that green one here, that also would be measured as 2 inches, but obviously the green and the blue line are not the same length. Precision is defined to be the ability to distinguish between similar objects. So this ruler here is not precise enough to distinguish between the blue line and the green line. Well, how can we make it more precise? Well, we can divide the units up. Now, one thing that always kind of puzzled me is when we do with inches, why do halves, quarters, and eighths? Well, it's quite simple. The technology they had back at that time, dividing it up into tenths was difficult to do. But if I want, let's say this is our measuring unit or an inch, to find a half inch, I just fold it over. There's a half inch. Fold it again, and I have a quarter inch. So it was relatively easy to find the middle or the halfway point. So that's why we ended up with halves, quarters, eighths, sixteenths, and on that pattern with our standard measurement. So if I want to make it so I can distinguish between that blue and green line, I can make this more precise by doing just that. I'm going to cut each of these units in half. Well, unfortunately here, both the blue and the green line are still closest to the 2.5. So it is still not precise enough to distinguish between them. So we'll cut them in half again, get our quarters. Now I would say it's a little close, but I'd say the blue one is slightly closer to 2.5. And the green one is slightly closer to 2.25 inches. This is called the degree of precision. I made this ruler more precise by cutting the units into smaller fractions, smaller pieces. The degree of precision of a measuring device is the smallest division on that ruler. So here the smallest division is a 1/4 inch. So for this ruler, the degree of precision is a 1/4 inch. It's precise to a 1/4 of an inch. But you will notice that that green line is not exactly on the 2 1/4, and the blue line is not exactly on the 2 1/2. They're simply closest to those. In fact, for the 2 1/4, anything between here and about here would have been measured as 2 1/4. Well, that distance on either side is called the possible error. So the possible error in a measurement is always equal. You can see it goes halfway to the next division. So it is 1/2 times the degree of precision. Now, it doesn't matter if you use 1/2 or 0.5. In this case, with the 1/4 inch degree of precision, 1/2 times 1/4 is probably easier to do. So that's 1/8 inch. So that's plus or minus 1/8 of an inch is the possible error here. The plus or minus means that if we measure something, and this one measured out to be 2 1/2 inches, or 2 1/4 inches, whichever one we're looking at, the actual length of that can be off, could be smaller by 1/8 of an inch or larger by 1/8 of an inch, because it's halfway to the next division. But it measured as 2 1/4 inches in this case, because that's the division it was closest to. So if I have a ruler here, first thing I want you to find for me is the degree of precision. Well, some of you may have just recognized this the way this is set up. If not, you just count. You pick 2 whole inch marks. The 1 inch and the 2 inch is probably the easiest. And you count. There's 1, 2, 3, 4, 5, 6, 7, 8 divisions in 1 whole inch. If you have to, you can divide it out. 1 inch divided by 8 is 1/8 of an inch. So the degree of precision here, the smallest division on that ruler, is 1/8 of an inch. Next, then, I want you to give me possible error. Well, the possible error is 1/2 times the degree of precision. So 1/2 times 1/8 is 1/16 of an inch. That means it's plus or minus 1/16 of an inch. So anything measured on this ruler is really only within 1/16 of an inch. Now, because of that, because it's only within 1/16 of an inch, it could be 1/16 of an inch smaller or larger than the reported measurement. Every measurement has an implied range. Let's say we have an object that we report the measurement as 2 3/4 inches using this ruler up here. Well, that ruler has a plus or minus 1/16 of an inch error. So the implied range is that measurement of 2 3/4 inches minus 1/16 of an inch. 3/4 is 12/16, so 12 minus 1 is 11/16. That's 2 and 11/16 inches. To that reported measurement plus a 1/16 of an inch. So that's still 12/16 plus 1 is 13/16. That's 2 and 13/16 inches. So on this ruler, since it's precise to the 1/8 of an inch, means it has plus or minus a 1/16 of an inch error. If I report a measurement as 2 3/4 inches, what that's really saying is that that object is anywhere between 2 and 11/16 inches and 2 and 13/16 inches. Measurements are never exact. In other words, measurements are always rounded. And they're always rounded to the precision of the device. So let's take a look here. If I give you this ruler, like this, and if I tell you that a measurement is reported as 4.5 inches, find for me the implied range in your notes. Well, to find the implied range, we first have to find the degree of precision. If we count here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 spaces between 1 inch and 2 inch. That means that the degree of precision here is a 1/16 of an inch. Each division is only a 1/16 of an inch there. So the possible error is 1/2 times 1/16, or plus or minus 32nd of an inch. So that implied range, if it's 4.5, listed as 4.5 inches, is 4 minus a 32nd, or 4.5 minus a 32nd, to 4.5 plus a 32nd. 1/2, of course, is 16 32seconds. 16 minus 1 is 15 32seconds, so that's 4 and 15 32seconds of an inch. 2, 16 plus 1 is 4 and 17 32seconds of an inch. Now, this may seem a little tedious, but it is very important to understand what the true meaning of a measurement is if we're going to be doing a calculation with it. If you are doing a reverse engineering on a part, and you're trying to take somebody else's part and design something exactly like it, or at least similar to it, it's important that you know what degree of precision is necessary, or what degree of precision is used, so that you know how close you are to the actual measurement, the actual size of that part. If you're using a less precise measurement, your error is going to be bigger. Here, because our precision was down to a 1/16 of an inch, our error was only plus or minus a 32nd. Now for welding, a 32nd of an inch is actually pretty big. A lot of stuff you guys work with is going to be very precise. Of course, more so on the machining side of it, but you guys work hand in hand dealing with those parts. So it's not uncommon to have something more precise than a 32nd of an inch. One of the weaknesses of our standard measurement and our fractional measurement like this is we either have to have that measuring device in front of us so that we can see what the degree of precision is, or we have to be told the degree of precision. So we might be told that we have a measurement of 8 1/4 inches on a device with a degree of precision of an 1/8 inch. So if it's a degree of precision of an 1/8 inch, that possible error is 1/2 times 1/8, or plus or minus 1/16 of an inch. So that means our measurement really, even though it's reported as 8 1/4, is from 8 1/4 minus a 1/16 to 8 1/4 plus a 1/16. Well, 1/4 is 4/16, so minus 1 is 3/16. That's 8 3/16 inches to a quarter, still 4/16, so that's 8 5/16 inches. So as long as we know the degree of precision, we can figure out what that implied range is for that measurement. Well, it's actually much easier to do if we have decimal measurements, because the degree of precision is built right into the decimal measurement. Illustrate what I mean by that. If I have a measurement that's 2.3 inches or 2.30 inches, is there a difference between those two measurements? Well, your first instinct is to say no. They're mathematically 2.3 and 2.30 are the same. If you're after the decimal point, you can add zeros to the end of the number and it doesn't change its value. However, since these are measurements, there's an implication there. The 2.3 inches is implying that we have a measuring device that is capable of measuring to the nearest 1/10 of an inch. And that object was closest to 2.3 inches. In other words, the degree of precision is just the place value of the last digit in the number. Right there is the last digit of the number that is in the tenths place. So the degree of precision here is 1/10 of an inch, 0.1 inch. So the possible error well, rather than using 1/2 times the degree of precision, I'm going to use 0.5 times it just because it works easier with decimals. So that's plus or minus 0.05 inches. So as you can see from the illustration, that gives us an implied range. I'm just going to write range instead of implied, of 2.25 inches to 2.35 inches. It can be off by as many as 5/100ths to either side. This, of course, would be 5/100ths of an inch. The 2.30 inches is implying that we had a measuring device that could measure to the 100th of an inch. And it's still closest to the 2.3. So you can see that's in purple there, that's a much smaller range. Because there's that extra 0 on the end here, this is implying a degree of precision that is in the hundredths place, so a hundredth of an inch, which implies a possible error of 1/2 or 0.5 times a hundredth, which is plus or minus 5/1000ths of an inch. So the range that's implied by that measurement is 2.295 inches to 2.305 inches. A much smaller range, as you saw right here, that purple range as opposed to the red range on that ruler. So it's tempting, if all of your other measurements are reported to 2 decimal places, to just throw that extra 0 on the end of a measurement. You've got to resist that urge, because by putting that extra 0 there, you are telling whoever is going to read that measurement or possibly use it for a calculation later that that object was measured to the 100th of an inch. And if it really wasn't measured to a 100th of an inch, then you're using a degree of precision that isn't real. It's not true. It's a false degree of precision. So find the implied range for each of these measurements. For one here, is 32 inches, and for number 2, 4.83 inches. I'll give you a couple minutes, and then we'll go over those. So to find the implied range, the first thing we have to find for each of these is the degree of precision. Remember, the degree of precision is just the place value of the last digit. This is in the ones place, so that degree of precision there is just to the nearest 1 inch. So that means our possible error is half of that, 0.5 times 1, is plus or minus a ½ inch. So that gives us a range of 32 minus a ½ inch, 31.5 inches, to 32 plus a ½ inch, or 32.5 inches. Obviously, measuring something to the nearest inch, to just the nearest inch, is not an acceptable degree of precision in most cases. Number 2 here, our degree of precision, that last digit is in the hundredths place, so it is 0.01 or a hundredth of an inch. So our error is 0.5 times 1/100th, which is plus or minus 5/1000ths of an inch. 4.83 minus 5,000 is 4.825 inches. To 4.83 plus 5/1000ths is 4.835 inches. Well, I think that's as long as my voice is going to hold out today, so I'm going to give you some homework here. In your textbook, Page 173. Exercise 4.2, 1 through 29, the odds. Starting tomorrow, we're going to use some packets. They're out there on Blackboard, or they will be out there on Blackboard at least, for calipers and micrometers. So make sure that if you get a chance, you either print those off or have access to them so you can work on them. Tomorrow, we actually do go over calipers. Anybody have any questions? Okay.